Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like coordinate geometry, quadratic equation, inequalities, maxima minima, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, plotting of algebraic functions like the linear functions, quadratic functions, and so on. And in today's video, we'll be seeing the graph of linear functions. So let us start with today's video. Let us start with a very basic linear equation, y equal to x. Well, before seeing the graph of linear equations, I would suggest you all to go through the coordinate geometry videos first and then to come back to this video, as the knowledge of coordinate geometry would be very much required in understanding the graph of linear equations, the link of which I have given above and also in the description box. So if we draw x and y coordinate axis, in that case, we can draw the graph of y equal to x. Well, in the coordinate geometry videos, we have seen the generic equation of a line in gradient form is given by y equal to mx plus c, where m is the slope or gradient of the line and c is the y-intercept. So if we compare the very basic y equal to x with the gradient form of line, in that case, the value of m would be 1 and the value of c would be 0. M equal to 1 indicates that tangent of the angle that the line is making with the positive direction of x-axis would be 1. That is, the angle would be 45 degree, as tan 45 degree is 1. And c equal to 0 indicates that the y-intercept of this line y equal to x is 0. That is, the line would be passing through the origin. So we need to plot a line which is making an angle of 45 degree with the positive direction of x-axis and passing through the origin. So if we draw the line would be something like this, where this angle theta would be 45 degree and the line would be passing through the origin. We can also verify this by plotting some random points in y equal to x line. For example, at x equal to 1, let's say somewhere here, the value of y will also be 1. In a similar way, at x equal to 2, say somewhere here, the value of y will also be 2. And at x equal to 3, the value of y will also be 3 and so on. And if we join all these points, we'd be getting this line. So this line represents y equal to x. In a similar way, say if we have y equal to 2x line. In that case also, the y-intercept c would be 0, but the slope would be 2. That is, tangent of the angle that the line is making with the positive direction of x-axis would be 2. So the angle would be more than 45 degree and that line would be passing through origin, as the y-intercept here is also 0. So the line would be something like this, where the line is passing through the origin and is making an angle which is more than 45 degree. In a similar way, if we increase the coefficient of x, that is, let's say if we assume y equal to 3x line, in that case, the slope would be 3 and this line will also pass through the origin. So this line would be something like this. So we can see that if the gradient value is higher, in that case, the line would be tilted towards y-axis. In a similar way, say if we have the line as y equal to minus x. In this case, the value of the slope m would be minus 1. So tan of the angle that the line is making with the positive direction of x-axis would be minus 1. So this theta would be 135 degree or 45 degree with the negative direction of x-axis. And this line will also pass through the origin. So if we draw this line, in that case, the line would be something like this. That is passing through the origin and making an angle of 135 degree with the positive direction of x-axis, or making an angle of 45 degree with the negative direction of x-axis. So this line represents y equal to minus x line. In a similar way, if we want to draw the line y equal to minus 2x, in that case, that line will also pass through the origin and would be something like this. That is, would be tilted towards the y-axis. In a similar way, y equal to minus 3x would be on the right side of this line, and that would be something like this, that is passing through the origin again, since the y-intercept here is 0. So we can see that when we increase the magnitude of the slope, the graph of the line is tilted towards the y-axis. So when we decrease the magnitude of the slope, in that case, the line would be going away from the y-axis. For example, y equal to 1 by 2x graph would be on the right side of this black line, that is y equal to x. So this would be y equal to 1 by 2x. In a similar way, the graph of y equal to minus 1 by 2x would be on the left side of y equal to minus x. So y equal to minus 1 by 2x would be something like this. So this line would be representing y equal to minus 1 by 2x line. Some of you might get confused why y equal to minus 2x line, minus 3x line, etc. has been drawn on the right side of y equal to minus x line, whereas y equal to minus 1 by 2x line has been drawn on the left side of y equal to minus x line. Well, one thing that we can do to verify is finding the approximate angle that the line is making with the positive direction of x-axis, just the way we did for y equal to minus x line, and the angle comes to be 135 degree. Or what we can do is we can simply put some random points and we can check the value of y. For example, at x equal to minus 1, the line y equal to minus 1 by 2x will give us the value of y to be 1 by 2, say somewhere here. But y equal to minus x will give us the value of y to be 1, that is above this 1 by 2, let's say somewhere here. In a similar way, y equal to minus 2x or y equal to minus 3x will give us the value of y to be plus 2 and plus 3 at x equal to minus 1. So y equal to minus 2x line, minus 3x line, etc. will be on the right side of y equal to minus x line, whereas y equal to minus 1 by 2x line, minus 1 by 3x line, etc. would be on the left side of y equal to minus x line. So we can say that when we increase the magnitude of the slope of the line, in that case, the line would be tilted towards y-axis and vice versa. In all the previous cases, we have seen the graph of lines when the y-intercept is 0. Now let us see the graph of line when the y-intercept is non-zero. Let us consider this line y equal to 3x plus 6, and let us see the graph of this line. Again, if we compare this line with y equal to mx plus c form, in that case, we can say that the slope would be 3 and the y-intercept c would be 6. Since the y-intercept is positive, so the line would be passing through a point which would be above the x-axis, and that point would be 0, 6. Let us put 0, 6 to be somewhere here. And we have the slope m equal to 3, which is positive, and we know that when the angle is lying between 0 and 90 degree, in that case, the slope m is positive. So from this, we can say that the line would be making an angle which would be between 0 and 90 degree with the positive direction of x-axis. And the line is passing through the point 0, 6. So the line has to be something like this. So this represents the line y equal to 3x plus 6. There are also another ways by which we can plot this y equal to 3x plus 6 line on the x and y axis. We know that we'll be getting the x-intercept when we put y equal to 0. So when y is 0, in that case, 3x plus 6 would be 0. So x would be minus 6 by 3, which would be minus 2. That is, the x-intercept is minus 2. And we know that the y-intercept is 6. So we need to draw a line whose x-intercept is minus 2 and whose y-intercept is plus 6. So that means the line would be passing through these 2 points. So the line has to be this line. So either we can compare the line with y equal to mx plus c form, or we can find the x-intercept and y-intercept to plot the line on x and y coordinate axis. In a similar way, say if we want to plot this line, say y equal to 2 by 3x minus 4. So again, here we can find the x and y intercept and we can plot this line. So to find the x-intercept, we can put y to be 0. In that case, the value of x would be 6. And if we put x to be 0, in that case, the value of y would be minus 4. So the x-intercept is 6 and the y-intercept is minus 4. So the line would be passing through the point 6, 0, which would be somewhere here, say, and it would be also passing to the point 0, minus 4, let it be somewhere here. So the line has to be this line. So this line represents y equal to 2 by 3x minus 4. So in this way, we can plot linear functions on x and y coordinate axis. Now, let us see the graph of linear inequalities. The linear inequalities given here is y less than x, y less than 2 minus x, and y greater than 0. And we need to find the graph represented by these 3 inequalities. The graph of linear inequalities won't be a line, rather it will represent a region. For example, y equal to x would be this line, and this region will represent all values of y which would be lesser than x, and this region will represent all values of y which would be greater than x, and this is the line which is representing y equal to x. We can also verify this by checking some random points in these regions. For example, all the values of y and x on this line would be equal. For example, we'd be having a point 1, 1, 2, 2, 3, 3, and so on this line y equal to x. Now, let us consider a point which is lying in this region, that is y less than x. We know that we'd be having a point somewhere here, say 4, 0, and here the value of x is 4 and the value of y is 0. And we know that 4 is greater than 0. So we can say that this would be representing the region y less than x. In a similar way, let us consider a point on the region y greater than x. For example, let us consider a point here, say 0, 4. So here the value of x is 0 and the value of y is 4. And we know that 0 is less than 4. That is, the value of y is greater than x. So y greater than x would be represented by this region. In a similar way, to draw y less than 2 minus x, first we need to draw the line y equal to 2 minus x. And to draw y equal to 2 minus x, we can simply find out the x and y intercept. So the x-intercept would be when y is 0, which will give us x to be 2. And the y-intercept would be when x is 0, which will again give us y to be 2. So x equal to 2 would be, say, somewhere here, and y equal to 2 would be, say, somewhere here. So y equal to 2 minus x would be this line, but we require all those values of y which is lesser than 2 minus x. So y less than 2 minus x would be represented by this region. We can again verify this by taking some random points on this region. Let us take the point to be origin here. So y would be 0 and 2 minus x would be 2 minus 0, that is 2. And we know 0 is less than 2. So y less than 2 minus x is represented by this region. Now let us see y greater than 0. We know y equal to 0 is represented by the x-axis. So y greater than 0 would be above the x-axis. That is, this region would be representing y greater than 0. Now, the region that would be satisfying these three inequalities would be the triangle formed by these 3 points. That is, this would be that region which would be satisfying all the 3 inequalities. In the competitive exam, the question can be to find the area of this region. Since this is a triangle, so we can find the area simply by using half into base into altitude, or simply by using the area of the triangle when we know the coordinates of the 3 vertices of the triangle, which is given by area of the triangle as half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, where x1 y1, x2 y2 and x3 y3 are the coordinates of the 3 vertices of the triangle. Here the points would be origin. Let us name this point to be O, whose coordinate would be 0, 0. Let us name this point to be A, whose coordinate would be 2, 0. And let us name this point to be B, whose coordinate would be the intersection of y equal to x and y equal to 2 minus x line, which will give us the point as 1, 1. Now we can put these values into this formula and we can find the area of the triangle, or we can directly use area of the triangle as half into base into altitude. Since here using this formula would be easy, so let us use this. So area would be half into base into altitude, that is half times of base, which would be OA, that is 2 units, times of altitude, that is perpendicular from the point B on the line OA, which would be of 1 unit. So the area would be 1 square units. We can also verify this area simply by putting these points into this formula, that is by putting x1 y1 as 0, 0, x2 y2 as 2, 0, and x3 y3 as 1, 1, and we'll find that we'll be getting the same area, that is 1 square units. So the area of the region formed by these 3 inequalities is 1 square units. So in this way, we can find the region and then the area formed by the linear inequalities. So that's it for today's video, in which we have seen the graph of linear functions. And in the next video, we'd be seeing the graph of quadratic functions and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.